designed to allow you to create your personal observatory. Here you have the Celestron Edge HD 14 inches. The Edge HD 14 inches is the larger model of the Edge HD series, and thanks to its large 14 inches diameter is great both for visual and photographic application, both in high resolution planet and moon application, but also for deep sky, for galaxies, nebulas or star clusters. Edge HD optics are the evolution of the classic Smith-Cassegrain telescope. They have a lot of improvement. The most important one is the integration of a corrector that allow us to get pinpoint stars also with large sensor cameras. The big advantage of this system that is designed for astrophotography, in fact you can use at f10 or you can add the focal reducer here and convert the system to f7, or you can install the Hyperstar system instead of the secondary mirror and convert to a f2 astrograph. In order to use the Edge HD 14 inches for astrophotography, we can connect, for example, a cooled CCD camera, like in this case with a filter wheel and an off-axis guider that we always suggest when you want to take astrophotography picture with long focal length, and then control and power everything with the eagle that is directly installed and clamped on the Losmandy bar. This way we will have a very powerful telescope ready for the most demanding astro imaging and ready also for the remote operation. Wow, that's incredible to see and to think about the price so affordable of this Ritchie-Chrétien telescope, 8 inches by GSO, and it's an f8 real Ritchie-Chrétien telescope. Let's see the main features. Ritchie-Chrétien 8 inches model by GSO is really a portable and lightweight telescope, as you can see, as in this case we install on an advanced VX mount by Celestron. Let's see in detail the front side. You have the large secondary mirror that helps reducing the vignetting with the light baffles down to the primary mirror in the bottom. And then let's see the focuser on the back. It's a 2 inches model with a micrometric knob 110. There are many ways you can use this Ritchie-Chrétien telescope in astrophotography, but one is the one that I'm showing you. We have an off-axis guider here with the guiding camera here, and here you can connect a cool CCD camera, DSLR camera you may have. Then we installed the Sesto Senso robotic focusing system for the remote control of the focuser, and everything is controlled by the eagle that we can install on top of the telescope using the plus dovetail clamp here, so you can use the Vixen bar that is on top of the Ritchie-Chrétien by GSO. Side-by-side plates like this one allow you to install 2 telescopes on the same mount, or a DSLR camera with its lens. Let's see how to do that with the Plus system side-by-side plate. Thanks to modularity of Plus system, we have a complete line of side-by-side plate that you can choose that the best fit for your setup. In fact, when you have to choose a side-by-side plate, you have to consider the connection that you have on your mount. So you may choose the Losmandy style or the Vixen style, and then the separation of the 2 dovetail clamps based on the dimension of what you want to install on your mount. So we have larger one to shorter one. All the plus system side-by-side plate has on the telescope side the connection both for Vixen style and Losmendi style dovetail bars. But you can choose the dimension of the dovetail clamp with the standard model, with a large model with 2 elements, and the maximum model with 3 elements. And of course, the larger, the stronger the connection of the telescope, so it's better also for very heavy telescopes. Every dovetail clamp is installed on the dovetail bar with the true screws, and this is to prevent any flexure. And you can also choose to personalize the dovetail clamps you install on the dovetail bar. Like in this case, we install on one side the large model with 2 elements, and on the other side the standard model with a single element. I know what you're thinking. Radio telescopes are wonderful machines, but huge. So how can I have one really to use and compact? That's the Spider 230C, the most compact radio telescope that really lets you perform radio astronomy with an easy to use and compact system. Spider 230C uses a large 2.3 meter diameter antenna installed on a German equatorial mount, fully steerable, that allows precise tracking and pointing of different radio sources in the sky. It comes with a feed optimized for 1420 MHz frequency detection and dual LNA system for left and right polarization. Spider 230C comes with the same radio astronomy receiver we install in our larger radio telescopes. The H142.1 receiver is for 1420 MHz frequency. It has 50 MHz of instantaneous received bandwidth and 1024 channels. Everything is controlled by our Radio Universe Pro software, where you can see in real time the power spectrum with the FFT, the BBC tools, the offset alignment, the source visibilities, the gain calibration, the on-off feature both for continuous observation and spectra, the total power plots, and the mapping features. All of this in a system very easy to use and that doesn't need for a fixed installation. That's the Spider 230C, the compact radio telescope. Long before starting Primaluce Lab, we are amateur astronomers from many years. And I remember when still students, we saved some money just to buy the first telescopes. After 20 years of experience, a lot of nights observing and taking pictures of the sky, testing our innovation, we decided it was time for a challenge. In fact, there are large diameter telescopes, very good to observe the sky, but difficult to transport and to collimate. More compact telescopes, but more difficult to use when you want to take pictures of deep sky objects. Telescopes that make easy astrophotography of galaxies, nebulas or star clusters, but they are limited in visual use or for high-resolution planet and moon imaging. So our team went to work. We want to create a telescope that, using Primaluce Lab technologies, allow us to do everything from observation to photography, from high-resolution planetary and moon imaging to long exposure of deep sky objects. And we want it to be easy to transport, to set up and to power on the field, so we can use it even from the most remote locations, from light pollution. In short, we want the power of a small astronomical observatory with the portability of an amateur telescope. Hey, hold on, with this, we don't say that we have the perfect telescope. In fact, if you connect to our website, you can find a lot of telescopes, mounts, CCD cameras, accessories, and we can build hundreds of different telescopes. But for our challenge, we create one telescope to aim them all, one telescope to track them, one telescope to observe them all, and in the darkness, picture them.
Only one?
For our setup, we choose to use the Celestron Edge HD 9¼ model because for the 235mm of diameter allow you to really see deep sky object even, but also gives you high resolution capability, and this is great for planetary and moon imaging at high resolution. Also, the telescopes come with an internal field flattener that gives you a large corrected field, and this is great also for deep sky astrophotography. And the telescope is installed on an M1 mount by Avalon Instrument, and this mount is great even for astrophotography because the particular design allows you to have a great portability thanks to the lack of heavy counterweight, and the type of design has no backlash, so this mount works great also with autoguiders. For deep sky astrophotography of galaxies, nebulas or star clusters, we choose the ATIC 16200 camera, the monochromatic version with a sensor of close to 35mm of diagonal, and it's a perfect match with the large corrected field of the telescope. In front of the camera there's the motorized filter wheel for 7 filters 2 inches diameter, and in front there's the off-axis guider with the Lodestar monochrome camera as an autoguider. We will make great high-resolution planetary and moon imaging thanks to the use of a QHY 53290. And we will also observe through the telescope by using appropriate eyepieces and mirror diagonals. We will do a precision polar alignment thanks to the Polemaster by QHY CCD, and we will avoid that dew condense on the optics thanks to the Eco environmental module with temperature and humidity sensors. All this technology is controlled by the Eagle that allow you to remotely control and power all the devices. We install the Eagle in parallel to the main telescope that is free to move, avoiding problems with cables. This is a technologically advanced telescope that it will be a challenge also for us, but we will be together. So we will see how to observe, to take picture and to study the universe together. So follow us.